Now we're going to look at some matrices and we are going to read the solutions. So determine whether the system has a solution. If so, determine what the solutions are. Okay, so if we're looking at a matrix, the number of columns tells us how many variables or unknowns we have, and the number of rows tell us how many equations. So rows go sideways like rows in a field. So these are rows. And columns go up and down like columns of a building. It says 1, 2, 3 columns. We are always looking to the left of this vertical line. Okay, so there are 3 columns, which means there will be 3 variables or 3 unknowns. Okay, so they didn't tell us what variables to use, so let's just use X, Y, and Z for now. Sometimes you can use X1, X2, and X3, X4, X5, X6 if you want to, but for now let's use X, Y, Z. We'll change it up on a different problem. Okay, so there's 3 variables because there's 3 columns. Now we're going to look at rows. There's 1, 2, 3 rows. So that means there's 3 equations. 3 equations because we have 3 rows. If you have as many equations as you do variables, then you know you can have one solution, infinitely many, or none. So we're going to read each of these off. So let's start with the first row. We're going to say this is 1x plus 0y plus 0z equals 3. So 1x plus 0y plus 0z equal 3. But let's just write that as x equals 3. Because 0y and 0z are just 0. So now let's look at this row. So 0x plus 1y plus 0z equals negative 11. But again, here's a 0, here's a 0. So y equals negative 11. So that came from here. Let's look at the third row. 0x plus 0y plus 1z equals negative 8. So we see z equals negative 8. Okay, so that's if I just read it off. But we have done a good job in this matrix, whoever gave this to us. This is in what we call row-reduced echelon form. We see our ones make that stair step we like to look at. And we have unit columns. Remember, a unit column has 1, 1, and everything else in there is 0. So this is a unit column, and so is this, and so is this. So you can easily read off the answers, right? 1x equals 3. 1y equals negative 11. 1z is negative 8. So we see that we have 3 variables, and every single one of them is explicitly accounted for. So this has exactly one solution. Okay, let's try part B. So for part B, we see we have still 1, 2, 3 columns to the left of that vertical line. So we're going to have 3 variables or 3 unknowns. Okay, just to change it up a little bit, let's call them, let's call them x sub 1, x sub 2, and x sub 3. So we're going to read off our answers. We have 1, 2, 3, 4 equations this time. So let's just go a piece at a time. So looking at this one right here. 1x1 plus 0x sub 2 plus 0x sub 3 equals 71. So we simplify that to see that x1 is 71. Look at the second one. 0x1 plus 1x2 plus 0x3 equals negative 62. So x2 is negative 62. Look at the third one. 0x1 plus 0x2 plus 1x3 is equal to 31. So then we see that x sub 3 is 31. And then we look at the last one. 0x1 plus 0x2 plus 0x3 is 100. So we see 0 is equal to 100. Okay, well, we know that's garbage. 0 is not equal to 100. This statement right here is false. So that means there is no solution. Okay, even though x1, x2, and x sub 3 were explicitly solved for, we had a piece of information that was not true. So this will be no solution. This is also in that row-reduced echelon form. Here is your stair step like this. And the row-reduced echelon form says if there's a row of zeros, it's at the very bottom. And your ones make a stair step like this. And we see that we have a unit column here, and here, and here. 3 unit columns. But we have no solution because we have 0 equal to a non-zero number. Let's try another one. Okay, so For this example, we have 1, 2, 3 variables. Let's still use x sub 1, x sub 2, and x sub 3. But now we only have 2 equations. And we know that if we have less equations than variables, we will only have 2 choices. We can either have no solution, or we can have infinitely many solutions. You will never have exactly one solution when you have less equations than variables. Okay, so then we read this off. X sub 1 plus 0x sub 2 plus x sub 3 equals 43. So in other words, x sub 1 plus x sub 3 is equal to 43. And then 0x sub 1 plus 1x sub 2 plus 0x sub 3 is 106. So that one says x sub 2 is 106. Okay, so no solution is actually the easiest, right? A row of zeros equal to a number. So we don't have that case. So that means our answer is going to be infinitely many solutions. Okay, well, how do we do that? Well, we ultimately want an answer. We want x1 equals some number or some value. x2 equals some number or some value. And x sub 3 does as well. Okay, so that's our goal. Okay, we're going to try to get there. So if you notice, x1 and x3 are in the same equation. So let's skip that one for a second. We know x sub 2 is equal to 106. So I can say, well, x sub 2, that one's easy. That one is 106. I'm done. Okay, but then x sub 1 plus x sub 3 equals 43. So it would be helpful if I got x1 equals the rest of it. So I'm going to move this x sub 3 over. So hopefully you see, well, we have 43 minus x sub 3. Okay, do not make this a circular argument. If you have an x sub 3 on the right-hand side for x sub 1, it is certainly true that x sub 3 is still equal to x sub 3. But we don't really want our answer like that because we have a variable on the left-hand side equal to a variable on the right-hand side for both of these equations. So this is where you usually see something like this. We're going to let x sub 3, because x sub 3 is in both of these, we're going to let x sub 3 equal t, where t is any real number. Now t is called a parameter. It's any real number. So it's a real number, right? So we have x sub 1 equals 43 minus some real number. So this side now is a number instead of a variable and a number. So then we have x sub 2 is 106 and x sub 3 is t. And because t is any real number, we know there are infinitely many real numbers. This has infinitely many solutions. Okay, and this is how you write your solution. Okay, let's try another one. Okay, so for part D, we have, looks like we have 2 columns right here. So we have 2 variables, and I'm going to go ahead and use x sub 1 and x sub 2, and we also have 2 equations. So in this case, I still have all my choices. I can have exactly one solution, or I can have no solution, or I can have infinitely many solutions. Okay, so then we just read off our answers, right? We see that x sub 1 is 6, x sub 2 is -2. Well, that was easy. Both variables are listed there and they're both accounted for. We have an explicit equation. No other variables mixed in, so this has exactly one solution. Okay, let's try another one. Oh, look at I don't know why this is part D. Let's look at part E. Letters are different. So, 1, 0, 6, that looks familiar. 0, 1, -2, that looks familiar. There's a new row. Okay, does that change our answer? So this still has 1, 2, so it has 2 variables because there's 2 columns to the left of that vertical line. And then we have 3 equations. So again, I still get all 3 choices. So I'm going to call this x sub 1 and this x sub 2. So x sub 1 is 6, x sub 2 is -2, and the third row is 0 equals 1. Well, we know 0 equals 1 is not true. This is a false statement. So even if the other 2 were okay, this is a false statement. So this has no solution. No solution is the easy one, right? Okay, let's look at F. F, we still have 1, 2 variables. Okay, and then we have 1, 2, 3 equations because we have 3 rows. Okay, so again, I could have exactly one solution. We could have no solution. Or we could have infinitely many solutions. Infinite many solutions. Okay, so I'm going to go ahead and label this as x sub 1 and this is x sub 2. Let's read off the first row. We get x sub 1 is 6. That's easy. Read off the second row. X sub 2 equals negative 2. That one's easy. Okay. Read off the third row. 0 equals 0. Okay, it's not a false statement this time, so this is a true statement. Okay, so we know for sure that the answer is not no solution. So which one is it? Exactly one solution or infinitely many solutions? Turns out in this case, we have exactly one solution. And it's x sub 1 is 6, x sub 2 is negative 2. Remember, you could also write this as points. Okay, but you may be saying, wait a minute, 0 is equal to 0. That means infinitely many solutions. Not always. This, in this case, just means there was some redundant information. So we have two variables. That's why it's so important. I start every time counting the number of columns. There are two variables, and they're both explicitly accounted for. And there's no extraneous information. Let me show you one more example. If I had something like 1, 0, 0, 6, 0, 1, 0, negative 2, and 0, 0, 0, 0, we have a different situation. Because here we have 1, 2, 3 variables, because there's 3 columns. And we have 1, 2, 3 equations, because there's 3 rows. Okay, let's go ahead and use x sub 1, x sub 2, x sub 3. We read off each row. X sub 1 is 6, that's easy. X sub 2 is negative 2, that one's easy. And 0 equals 0. Now look, very important you see that the equations I pulled out of the matrix are the same as the ones for the previous question. Okay, so right away we see we're not going to have no solution, because that one's the obvious one. The difference between these two problems is here I have 3 variables, and I don't have anything for x sub 3. Here I only had 2, and both of them were accounted for. So that means there's an x sub 3, and I don't know what it is, but certainly it's true to it. It's equal to itself, right? So what we're going to do is we're going to say, let x sub 3 equal t, which is any real number. Okay, and how many real numbers are there? Infinitely many. So then we have x sub 1 is equal to 6, x sub 2 is negative 2, and x sub 3 is t. So you could write your answer as 6, negative 2, and t, if you wanted to write it that way. And there are now infinitely many solutions. Okay, so let's look carefully. These look very, very, very similar. When I pulled them out of the matrix, they looked exactly the same. The difference was I had an additional column here. So that column represented a variable, and I have to take that into account. Okay?